Okay, this is one of the sample problems, sample problem 1.6. Perform the following arithmetic operations and report the result to the proper number of significant figures. And this particular question has 5 parts to it. So let's take a look at the first part here. Part A says that we're going to add two numbers together. 317.5 milliliters, ml is milliliters, that's a volume measurement. And we're going to add to that 0.675 milliliters, another volume measurement. So with this particular type of problem, when you're adding or subtracting, what you do is you line up the digits. So notice I'm putting the decimal points right on top of each other, and then writing the digits that come after that. This is plus. So then you add them up. So there's nothing here, there's a 5, so that's 5. Nothing here, plus a 7, so that's 7. 5 plus 6 is 11, so 1, carry the 1 there. There's our decimal point, that makes that an 8, and then a 1 and a 3. Now, here's the idea behind significant digits and addition subtraction. The answer cannot be known to a degree any greater than any of the measurements that were used in the calculation. So the first number, the 317.5, only goes out to the tenths place, whereas the second measurement, 0.675, goes out to the thousands. Our answer can only go out to the tenths because the first measurement, 317.5, only goes out to the tenths. So we would stop with the 1, but the number that comes after it is 5 or greater, so we round it up to a 2. So this becomes 318.2 milliliters. So that's addition subtraction. Let's take a look at B. B is also addition subtraction. This one is a subtraction problem. So again, you line them up with the decimal points essentially on top of each other. 2.075. And then here we're going to do our subtraction. So we're going to have to do some carrying on this one. So that's a 5, that's a 2, that's a 7, and then that's a 5, and then that's a 4. Now, this first measurement, 47.80, only goes out to the hundredths place. So our answer can only go out to the hundredths place. The digit that follows it is a 5 or greater, so we round it up. So this becomes 45.73, and then this is in liters. Okay, there's our answer for that one. Let's move on into part C. In part C, it's 13.5 grams divided by 45.18 liters. So if we're doing multiplication or division, the units don't have to be the same. They do in addition subtraction. 45.18 liters. Now the rules of addition and subtraction are different. With addition and subtraction, all you need to do is count the number of sig figs in each of the measurements and then pick the smaller number for your answer. So this numerator has 3 sig figs, 1, 2, 3, or sig digits if you're using the terminology in ALEKS. 4 in the one on the bottom, the denominator. So you pick the fewer number of sig figs. That's 3. This one only has 3, so our answer is going to have 3. Now with this one, to do the calculation, I'm going to pull out a calculator and do 13.5 divided by 45.18. And I'm going to go ahead and write out a bunch of digits that the calculator gives me. So 29880,478. I'll worry about the units in a moment. But since this numerator only has 3 sig figs, our answer has to have 3. So 1, 2, 3. Remember, leading zeros do not count as sig figs. The number that comes after it is 5 or greater, so we round it up. So this is going to become 0.299. Now let's go back to the units. Grams divided by liters. That's mass over volume. We might recognize that as a density calculation. So the density of this substance is 0.299 to 3 significant figures grams per liter. Probably a gas. Let's take a look at D. D says that we're going to take 6.25 centimeters and we're going to multiply that by, I'm going to put it in parentheses instead of using the symbol for multiplication, times 1.175 centimeters. Okay, so again, same idea, multiplication, division. Pick the measurement that has the fewest number of significant figures, and your answer will have that many. So the first measurement has 3, the second measurement has 4, so our answer should have 3. So you go ahead and you carry out the calculation on your calculator, and you get 7.34375, but we're going to round this to 3 sig figs because the first measurement here only has 3 sig figs. So 1, 2, 3. The number that comes after that 4 is below 5. So we just truncate it. So this is approximately 7.34. Again, centimeters times centimeters, centimeters squared. That's an area calculation right there. Calculating an area. So there's D. And now let's take a look at the last one. If you take a look at the last one, it's an interesting question. I'm going to go ahead and pull this up. Oops, sorry. I'm going to pull this up and get rid of A so that we have some room there. And maybe actually we'll get a little bit more of it so we have plenty of room. There we go. So let's take, we now have room for E, so let's take a look at this one. Sorry. Okay. So there's E. So we have 5.46 times 10 to the 2 grams, and we're adding to that 4.991 times 10 to the 3 grams. Now there's a little bit of notational problem here when I copied and pasted from the eBook into this document. Though the 2 and the 3 after the 10s are supposed to be exponents, not subscripts. So it's 10 to the 2 and 10 to the 3, 10 raised to the 2 grams and 10 raised to the 3. Now here's an issue. If you're adding or subtracting numbers and the exponents in the powers of 10 are not equal, you cannot add them directly. It's confusing if you do. So what I would recommend doing is taking one of those two numbers and converting the exponent so that it's the same as the other one, or writing them in decimal notation. Let me try the second method here. Let's write them in decimal notation. 5.46 times 10 to the 2. Well, 10 to the 2 is 100. So that's 5.46 times 100. Well, 5.46 times 100 is just 546. And now let's do the same thing with the second number. 4.991 times 10 to the 3. 10 to the 3 is 10 times 10 times 10. That's 1,000. So this is 4.991 times 1,000. Well, that's 4,991. Does that make sense? So now you can add them because they're decimal numbers. Decimal numbers can be added directly. So I'm going to write the 4,991 first just to make it look a little bit more pretty. And then again, we're adding these. So 546. And then 1 plus 6 is 7. 9 plus 4 is 13. 9 plus 1 is 10 plus a 5 is 15. And there we go, 5,537. Now, we're adding grams, grams and grams. Remember, if you're adding or subtracting numbers or measurements, the units have to be the same. So there's your 5,537 grams. Now, suppose we want to put this in scientific notation. The decimal point is assumed to be here, so we move it over 1, 2, 3, and that becomes 5.537 times 10 to the 3 grams. Now, one thing that I haven't really done is I haven't considered significant digits, but it actually worked out okay because I put these in decimal notation. The decimal point's there, decimal point's right there. So the first and the second number, the most precise value that we have in those measurements is in the ones column. They're both in the ones column. So that means that our answer is going to be in the ones column. So 5,537 grams or 5.537 times 10 to the 3 grams. So there you go. There's our answer for part E. Practice the, this is the sample problem, practice the practice that comes after it, A and B. Make sure you do the checkpoints and then do some of the end of chapter problems as well.